Building software takes a lot of time. Even the most skilled engineers spend the bulk of their day typing out lines of syntax, hunting down stray bugs, and writing out repetitive documentation. It is highly manual labor. Over the last year, AI coding assistants have stepped in to help. But most of these tools operate as advanced autocomplete. They suggest small snippets of text, but they lack the context of how those snippets fit into a project's broader architecture. Because the AI lacks that project-wide perspective, developers still do the heavy lifting themselves. They have to stitch everything together, run the tests, and manually trace errors across a dozen different files. Imagine giving a simple instruction: develop an industrial IoT dashboard, and watching the system generate the entire application structure, test it, and fix its errors. This is the concept behind Google Antigravity. It is an AI-powered development environment built to assist software engineers throughout the entire software development lifecycle, including planning, code generation, testing, and deployment. Antigravity functions as a development partner, coordinating the logistics of building and managing an application from a single, unified interface. To understand how it handles that lifecycle, let's look at the actual workflow. It begins with the user describing what they want to build using plain English instructions. This diagram shows the steps the system takes next. Before it writes a single line of code, the AI analyzes the request and generates a comprehensive implementation plan to define the architecture. Only after that plan is set does the system move to the generation phase. It begins writing the code, building the necessary functions, setting up the APIs, and even assisting with the initial testing runs. Because the AI follows this structured step-by-step logic, your primary job is to review and refine the solution before it gets deployed. By removing the manual setup time, the total hours required to build an application decrease. Scaling up to larger codebases is often difficult, but Antigravity includes a multi-file editing feature. If you need to make a structural change, the AI can assist in applying that update across your entire project simultaneously. It also provides active debugging assistance. Instead of forcing you to hunt through console logs, the system identifies coding errors as they happen and suggests immediate fixes to keep the project moving. While the software is being built, the platform generates the required code comments and project documentation in the background. By absorbing these specific tasks, the wide-scale refactoring, the bug hunting, and the documentation, the platform handles the repetitive aspects of the job. This workflow is effective for rapidly prototyping common software, like business websites or e-commerce platforms. You can get a working model up in a fraction of the usual time. The system also manages the intricate data pipelines required for Industry 4.0 applications. It can handle the telemetry needed for networks that track smart agriculture data or monitor output across a solar energy grid. For industrial automation, it can synchronize the logic between web-based SCADA dashboards and the specialized code that runs programmable logic controllers on a factory floor. By coordinating these different code bases and communication protocols, Antigravity builds the dense, data-heavy systems required for physical infrastructure. This shift changes the day-to-day work of the software engineer. The human developer is not being replaced. Instead, the job is evolving from a manual typist to an architectural director. This transition requires a new set of skills. Developers now need to master prompt writing to instruct the AI effectively, and they must review all of the code the system generates for accuracy. You cannot accurately review code if you do not understand how it works. Engineers must still possess a deep grasp of programming fundamentals to validate the AI's logic and catch edge cases. The human engineer is still responsible for the final product. You remain the final decision maker for system design, code quality, and the protection of sensitive security information. As cloud-native development and agentic AI workflows continue to mature, their success depends on humans using AI as a powerful assistant, guided by actual engineering judgment. Applying smart technology to streamline software development is exactly how we approach building powerful solutions for the physical world. That is why we are proud to feature DEVI automation solutions. They provide complete end-to-end solutions spanning industrial automation, the industrial Internet of Things, artificial intelligence, and smart factories. Their team brings deep hardware and software expertise to the table, handling everything from PLC programming and HMI development to complex SCADA systems and VFD drives. If you found this video helpful, please like, share, and subscribe to DEVI Automation Solutions for more educational content on AI and emerging technologies. You can reach out directly via the email address on screen to get started today.